Hi folks, DMX Electric here. Today, in this video, we're gonna show how we upgrade from an old stab-lok panel to a brand new Etan panel. And this is part of our legal basement build project, so stay tuned. Subscribe and stay tuned. Over the years, we see weird location where the electrical panel is. Stairways, right behind the door, in closed closet, in bathroom, or even right on top of a tub. This secondary suite, all called the legal basement, is the lower part of a rental property. We have the tenant right now living upstairs. We don't have any tenant living in the basement, of course. So the project need to be time sensitive, cost effective, and in the long run need to be low maintenance, which means we need to use good material, good workmanship, so make sure the landlord won't spend too much money and time on maintaining this property. The electrical panel we're going to use here is the Etan load center 20/40 circuits with a 100 amps main breaker for 120 and 240 volts. The reason we choose this one is, first, it's very cost effective and from a very reliable manufacturer. We can use the reliable circuit breaker, cutter hammer, and there's enough room for future upgrade, enough circuits, and after calculate the load calculation, we know we can do even an EV charger for this property. For the consumer service cable, we choose the ACW 3 conductor number 1 odd AL cable. So without changing anything, the customer can upgrade his service, bump up to 125 amps without any problem. We also need to build an electrical panel backing plate here. We use the high quality 3/4 of an inch sanded plywood here. You also notice that on the back of the backing plate, we use 2 pieces of 2x4 stud here, because in a customer's basement, there's only bare concrete wall, so we need to put insulation in between so the condensation won't build up. This is how it looks like after we install the backing plate and electrical panel on the wall. And you can see we also terminated one side of the service cable into the electrical panel. There are a couple of things worth to take a look at here. First is the neutron bound jumping screw. So we do need this thing at the main panel. So basically we connect the neutral bar to the panel itself. But this is not required at the sub panel. Actually, you cannot have the jumper screw in your sub panel. So secondly is the cable bending radius. So for this low voltage cable, you can bend like bigger than 6 times diameter of the cable. So if you bend the cable too much, you actually put stress on the cable, especially if you're dealing with the aluminum conductors. And after that, we also need to talk about the torque of the 2 breaker screws here. Again, this is breaker is rated for aluminum and copper, but you do need to apply certain torque on the screw, so make sure you have good connections here. So a lot of time you have problem is you have bad connection between the breaker and the cable. And then you can see here we have like a stripped piece of insulation off here. That is required by the code. Because we are using the ACW cable, so we don't have a big connector here. So in order to get good connection, we have to strip a little bit of insulation and put connectors here. But if you are using a tech cable, use a tech connector, that will be a different thing. Also, you notice that we used a white electrical tape to mark the 3 conductors of the service cable. You need to mark the 3 cable right after you strip the service cable, because those marking on the conductors comes off really easy. I believe over certain size of cable, they don't color coded the conductors anymore. So in this case, we either use the colored heat shrink to shrink those conductors, or we simply use the electrical tape to color them accordingly. And you can see our new service cable will run from the new electrical panel all the way down to the crawl space, which is under the stair between the main level and the basement, right into that hole to the bathroom in the basement. Then it goes up through the floor joists to outside of the house through the LB right into the meter base. As you can see, this is our temporary wiring for the upstairs tenant. So throughout our renovation progress, we always have tenants living upstairs. So we do want to minimize the downtime. So basically, we run a 3 conductor number 6 from the old panel to the new panel. So the upstairs tenant have a reduced capacity power supply, but it can run almost everything she wanted. So once we are ready, we simply remove the older electrical panel and swap to the new one. So in this way, we minimize the downtime for the customer. So when we swap to the new electrical panel, for those wires which are long enough, we simply terminate the wire into the new panel. But for those wires which are too short, we need to put a junction box in between the older wire, the new wire that goes to the electrical panel. So we have to refer back to the electrical code to find the proper size of the junction box, not only to meet the coding requirement, but also make our work easier. Guys, as you can see, this is the junction box for those short cables for the newer panel. So we have to have a junction box so we can split the shorter cable with the new one, so we reach to the newer electrical panel, and the older ones were coming from the top of those connectors into the 8x8 and by 4 junction box. Actually, we don't have to use this type of metal wire connector. We can use this green ones, but this one gives you better mechanical protection, and it will secure the cables here, no problem. And on our new panel side here, I got the wire number 1, number 2. I need to temporarily terminate those two into the electrical panel, so the customer will always have power there. But we have to make sure we have long enough, not only the hot, but also the neutral. Because this is a very old panel and doesn't mark anything about like which circuit is which. And according to the new electrical code rule, certain receptor need to be arc fault combination type. So basically, it protects you from the series arc fault and the parallel arc fault, which require the neutral to terminate into the breaker, not just to the neutral bar in the electrical panel. I will show you guys later how the combination type of arc fault breaker looks like. You can see I connected the first 2 wires together to the new panel, and when you twist the 2 wires together, always make sure it's good connection, especially when the 2 wires are not the same gauge. You have to make sure you have good twist. Otherwise, when you put the marrettes there, actually the bigger wire will try to push the smaller one out of the thing. So that's why I always put some electrical tape here not only make sure good connection and no exposed wire, also make sure the wire does not coming out of the marrettes. And one more thing, when you put the electrical here, tape here, try to keep the same direction as the way you twist the marrette and the way you twist the two wires, so they're not working against each other. So always use a bigger junction box when you relocate your panel, so you have more room to work with, and for later maintenance is also easier. And you can see the first two wires, 1 and 2, works here, 1 2, so will be like 1 2 3 4 5 6. We have like 13 wires here in total, so will give us a lot of room to work with. I don't know if you guys can see here, this neutral wire is squeezed really good here. I think they tied when they install the cable here, they tied the connectors too tight, so they squeezed the neutral wire too much. And that is everything for my panel upgrade part 1 for today.